All right, moving on to page 2 of our application notes. Finding the volume of a parallelepiped. I don't know why I love that word, I just think it's cool. Parallelepiped. So our adjacent edges are vectors though. So we have to have the edges as vectors, and adjacent, they all share a single vertex. So they all come from the same vertex, and so we have these three vectors that make up part of the parallelepiped. And so our formula for volume, plus or minus, and it's just the determinant where we put in the three vectors. So we're in space, it's a 3D object, so we're in space, so we have three parts to each of our vectors. And just like the area of the triangle, the plus or minus is a choice. You use the one to get the correct positive volume, because volume cannot be negative. Alrighty, so example, we have these three vectors that are the edges of a parallelepiped. Okay, and they are adjacent edges, so volume equals plus or minus the determinant, and I just put the three numbers across each row. And because the bottom row had a 0, I'm going to expand by minors using the bottom row. So positive, negative, positive, so I'm going to start with a positive, so plus, minus, plus. Then looking at the 2, cross off that column and that row, and we're left with 2, negative 1, 2, 2. Then looking at the 0, cross off that column and that row, and we're left with 1, negative 1, negative 1, 2. And then looking at the 1, cross off that column and that row, and we're left with 1, 2, negative 1, 2. Our 2 by 2 determinants, remember, down diagonal minus the up diagonal, so 4 minus negative 2. Down diagonal minus the up diagonal, but we really don't care because we're multiplying by 0. And down diagonal minus the up diagonal, so 2 minus negative 2. So this one ends up being 2 times 6, which is 12, plus 0, and this is 1 times 4, which is 4. So we get 16, and we want it to be positive, so we just keep the positive 16, and this is units cubed, as it is volume. And that finishes up all the notes for Unit 7 matrices. Thank you.